So I wanted to give a somewhat more complete example of doing some file I/O with a parser, just see how we can put some of these pieces together to do something a little more practical. Maybe this will help some of you on your final projects. If it doesn't, you feel free to ignore this. But let's see how this works. So a couple things. So first of all, I'm going to enhance. So this is some code that we wrote in class the other day. I'm going to improve this slightly. So first of all, let's just make spaces be able to handle like new lines or space. So you can have any sequence of white space. I mean, we could even do like tabs and stuff if we wanted to. I'm not going to worry about tabs right now. And then we had this function that gets some spaces and then parses an integer. And this is something we're going to want to do. We might want to do often. So like we could make an abstraction for this and say, basically, if you have something that parses an A, then we can make it into another parser for A that will actually ignore spaces first and then parse the A. So token P is just like you do spaces and then P. So we don't really need pos int T. When we say pos int T, I can just say, token pos int. Or I could just define it that way. Let's see, we don't actually want this version of parse list. I'll comment it out for now. So this one, right. So parse list, we can actually make this a little more general too, because we're specifically here reading in a number and then parsing some number of positive integers. But what if you want to parse some number of something else? We could easily generalize this, and we'll call this parse number of. So we're going to give it a parser for one item, and what we're going to get back is a parser for a bunch of items. But how this parser is going to work is that it's first going to parse a number, and then it's going to expect that number to tell it how many things to parse afterwards. So it's not like the many function, which just parses as many as it can. This is going to parse a specific number based on what it reads. So, so we say parser P. So the only thing we change is that this is going to be P now, right? I use pos int T to parse a number n, and then I'm going to n times I'm going to parse with the parser P. And then, so parse example file. So let's say, before we were talking about this format where we have a number and then we read that many numbers. What if we have like one of those on each? We have a bunch of lines. First, there's a number telling us how many lines there's going to be, and there's a number of each line telling us how many numbers are on that line. So we could say parse number of. So we're going to parse a bunch of something, and that each something is going to be one line of the file that's going to have, again, a number, and it's going to tell us how many integers there are. So that's it. That's our whole parser. And this will be a parser. This will give us a list of lists of integers, right? So one entry per line, and then one list of integers for each line. It's important that I upgraded spaces to ignore new lines too, because like every time it goes to read a number, it may have to skip a new line to get down to the next line to read that number. But we can try this out quickly. So if I'd say run parser parse example file, I shouldn't call it. It's not really parsing a file. We're going to do that later. We're just parsing our example. So if I reload this, parse example, and if I give it like, there's going to be 3 lines. First line says there's one number with an, and it's 9, and then the second line says there's 3 numbers, 2, 5, 8, and the third line says there's 5 numbers, 0, 1, 2, 4, 5. I have to say run parser. Right, that worked. I get just, and I get a list of lists. Right, I get the 9 and the 2, 5, 8, and then these things. Okay. So, and if I add some more numbers on the end, right? It's gonna stop. It knows to stop there because the 3 told it how many lines to read, and then the number in each beginning of each line told it how many numbers to read. So when it got to here, it knew it was done with this line. It also knew that it didn't need to read more lines. So that stuff is left over. Okay. Now what if we wanted to, if we actually had a file with that contents in it? So like, so we can actually say, let's take this string that I made and we'll say write file example.txt. So write file takes a string, which is the name of a file, and another string, which is the contents to write, and it's an IO action that creates that file. So if I go look at example.txt, there it is, there's my file. So let's see if we can make something that will parse it from that file. So we can make a generic function called parse from file. It's going to take a string, which is the name of the file you want to parse, a parser, which is going to be used to parse the contents of the file, and what we're going to get is an IO action, which, when executed, might get you an A, right? Because if this parser, if the parser succeeds, then we're going to get an A, and if it doesn't succeed, we'll get a nothing. Now, of course, there's also the issue of what if the file doesn't exist. We're not going to worry about that for this example, but you could do that too. There's functions you can use to test whether a file exists. So we'll take the file name and the parser p, and we're going to say do. So the first thing we want to do is to read in the file. So there's complicated ways to do this, but we're going to use a very simple way, which is I'm just going to say read file name. Okay, so read file, it just takes a, well, okay, so file path really is just a string. Okay, so actually we could even use that here, why not? File path is just a synonym for string, but it's nice to say file path just so that someone calling the function knows that, oh, I should provide the name of a file here. So yeah, read file just reads in the entire contents of the file as a string. And then what we want to do with that string is give it to, we're going to say run parser p on s. That's going to give us a maybe pair of an A and a leftover string. We don't care about the leftover string. Actually, you know what? Maybe we do care about it, but we care about it in the sense that we want to make sure that this parser p is able to read the entire file. And we had a primitive parser called EOF that basically makes sure that you're at the end of the input. So doing this says parse p and then make sure that we are at the end, but return whatever p returned. So we don't need that. We could take it out if we wanted, but this will make sure that the parser succeeds in parsing the entire file and doesn't leave anything left over. So now I really don't care about the leftover string because it's going to be empty. So I can just say fmap first. So that this fmap is with maybe, right? So this returns a maybe. And I'm going to say if it was a just, then I'm going to apply first to project out the A out of the tuple. And then finally, this whole thing is a maybe A, and I want an IO maybe A, so I can just say return. Or I could say pure, same thing. Let's try it. So if I say parse from file example.txt, what happened? It didn't actually run it, it just showed me its type. Oh, because I didn't give it a parser, that's why. I want it to use this parsed example parser. And I got nothing. Okay, I wasn't expecting that. Oh, right, of course we did, because remember that we actually put this extra stuff in there. So that file has got this extra content at the end. So if I remove that, let's try it again. Okay, actually, you know what? It might be one other thing we might want to do, because actually there's a new line at the very end of the file, and if it didn't, no parser actually consumed that, so it would still be left with a new line, and so it would say, nope, you're not at the end. So we could stick in something to say, yeah, if once we're done with P, there might be some more spaces, and then you should hit the end of the file. So this, I think, ought to work. Yeah, so that works. And of course, you could, let's make something that's called some sum lists. So what this is going to do is going to read the contents of this first file according to this format. Right? It's going to sum each list that we get, and then write out a new file, create a new file on this file name, where it's got one line with the sum of each of each list. Excuse me. So we could say, in file, out file. So first we're going to call our parse from file function. So we'll call it, ML for maybe list. So we're going to say parse from file, in file, parse example. And then we could say, if, or we'll do a case ML of, we could have gotten nothing. So if we get nothing, we're just going to put strlen. We could say like in file is not formatted correctly. And otherwise, if we get a just, we're going to get a just LL is our list of lists. I'm going to say I want to map over that map sum. So it's going to add up each list in that list of lists. And then I'm going to, to each sum, I'm going to call show, which is going to turn it into a string. And then finally I'm going to do unlines on this, which is a function in the standard library that takes a list of strings and turns it into one big string by putting a new line character in between each one. And finally I'm going to write file, out file, that. We'll try this. So if I say sum lists example.txt, sums.txt, it ran, it didn't print anything. And if I go look at sums.txt, there we go, it's got the sum of each, right? So 9, and then what is it? 3 plus 2 plus 5, or 2 plus 5 plus 8 is 15, and so on. And if we were to go into example and make it wrong somehow, now if I call this, oops, what's going on? There we go. Now it prints an error message.